All right, settle in, cadets. Welcome to today's briefing. Have you ever looked up at the sky and just wondered how we went from pilots dropping handheld bricks out of flimsy wooden biplanes to fielding hypersonic, invisible wings that can strike literally any target on the globe without ever being detected? Well, today's explainer is a historical lecture on exactly that journey. We're going to trace a timeline of pure engineering madness and high-stakes ambition. We are looking at the machines that completely redefined global power projection. From the rattling, vulnerable frames of the Great War to the hypersonic ghosts we're projecting for the year 2050, this is the complete evolution of the strategic bomber. Okay, let's dive right into this. Our syllabus today covers 5 eras: tactical origins, high-altitude heavyweights, jet-age deterrence, the stealth paradigm, and finally, the 2050 battle space. Before we get into the weeds, I want you to internalize this historical roadmap. It's wild to think about how compounding technological advancements entirely dictate global power projection. We're moving from 1914's basic WWI biplanes straight to the piston-driven heavyweights of the 1940s. Then, we're thrust into the jet age of the 1950s, disappear into the stealth revolution of the 1990s, and finally, break the bounds of speed with the hypersonics of 2050. Each leap forward fundamentally rewrote the rules of aerial supremacy. Now, just so we're all operating from the exact same doctrinal baseline, let's lock down our core concept. A strategic bomber is specifically a heavy aircraft designed to drop large amounts of ordnance on distant targets to debilitate an enemy's capacity to wage war. We absolutely must distinguish this strategic power projection from mere tactical battlefield support. We aren't just talking about supporting infantry on a front line. We are talking about destroying the adversary's industrial heart, their infrastructure, and their will to fight from thousands of miles away.
All right, part 1, tactical origins.
In those early days, the reality of aerial bombing was, well, it was remarkably crude. Pilots were quite literally flying in open cockpits and chucking small bombs or grenades over the side by hand. Just think about the pure madness of that for a second. You're flying a highly flammable wooden fabric kite, actively taking ground fire while casually holding a live grenade in your lap. But, the pace of innovation was relentless. By the end of World War I, we saw the introduction of iconic, giant pioneers like the Gotha GV and the Handley Page Type O. Now, make no mistake, these aircraft were incredibly dangerous to fly. They were painfully slow, extremely fragile, yet, despite their massive vulnerabilities, they proved a foundational military doctrine that holds true to this very day. If you control the air, you control the battlefield.
Let's move to section 2 and see how this builds. High-altitude heavyweights.
Consider this doctrinal shift for a moment. In World War I, the requirement was simply to harass enemy lines with whatever small payloads a pilot could manage to carry. But by World War II, the operational requirement had completely transformed. Let me ask you this, cadets. How do you deliver massive, war-ending payloads across entirely different continents and oceans, all while surviving highly coordinated, heavy anti-aircraft fire? The answer lies in mass payload delivery and unprecedented high-altitude survivability. The machines that actually answered that question became the heavy hitters of global conflict. First up, we have the legendary B-17 Flying Fortress. Its key innovation was its rugged durability. It earned a reputation for being absolutely unstoppable. It was able to absorb an extreme, almost unbelievable amount of battle damage and still keep flying its crew home. But the real game-changer of the era? That was the B-29 Superfortress. Its engineering leap was pressurization. This created a high-altitude monster with oceanic range that could operate way above much of the enemy flak, effectively ending the war and ushering humanity right into the heavy, irreversible reality of the atomic age.
Moving on to section 3, jet age deterrence.
You literally cannot study the jet age without talking about the B-52 Stratofortress. As we hit the 1950s, the era of propellers was out, and jet engines were officially in. The B-52 is this enduring engineering marvel that successfully swapped out those props for jets to achieve a level of unmatched global deterrence. It is so iconic and so fundamentally sound in its design that somehow, against all odds, it is still flying today, over 70 years after its introduction. And this brilliantly illustrates the rapid escalation of the Cold War. The overarching goal of this era was simple: faster, higher, and record-breaking performance. Nations pushed the absolute limits of aerodynamics at an incredible pace. We saw the introduction of the B-1 Lancer, which utilized swept wings to achieve actual supersonic flight. Over on the other side of the Iron Curtain, we saw their massive Soviet counterpart, the Tu-160. The result was a blistering, high-stakes race for aerial dominance, where the threat of mutually assured destruction hinged completely on the rapid capabilities of these very bombers.
Which brings us to Section 4, the stealth paradigm.
So the crucial point here is a massive doctrinal pivot. The Cold War requirement was essentially to outrun and outclimb air defenses. Put bigger engines on it, fly it higher, right? But the modern requirement realized that raw speed just wasn't going to cut it anymore. The new mandate was to evade radar entirely, remain completely invisible to the enemy, and strike with absolute pinpoint precision.
To achieve that invisibility, engineers had to embrace pure madness. Enter the B-2 spirit in the 1990s. It utilized highly advanced radar-absorbent composite materials and this radical flying wing shape. I mean, it looks like something straight out of a sci-fi movie, but it was designed specifically to bounce radar waves away. It became the ultimate stealth predator. And today, we're seeing the very next evolution with the B-21 Raider. It takes everything we learned from the B-2 and adds deep digital integration, designed for maximum efficiency and lethality in a modern, heavily networked battle space.
And that brings us to our final section. Part 5, the 2050 battle space. 5. That represents Mach 5, the hypersonic threshold. I really want you to think about the sheer gravity of this metric for a second. Flying at 5 times the speed of sound allows future strategic bombers to reach absolutely any target on Earth in under 2 hours. The staggering kinetic energy and speed involved here will fundamentally shrink the globe and basically eliminate an adversary's reaction time completely. Now, what's truly interesting is the projected escalation of this future warfare. We start with those Mach 5 plus hypersonic speeds, sure, but Step 2 introduces autonomous, loyal wingmen drones flying right alongside these bombers, massively multiplying their lethality. And by Step 3, we're looking at sub-orbital platforms operating on the very edge of space. But you want to know the most profound shift here? These are projected to be pilotless platforms. By 2050, the pilot will likely be completely removed from the cockpit, operating these fleets from secure, remote locations.
As our source material beautifully puts it, the evolution of the bomber isn't just about war. It's a testament to how far human engineering can go when we're pushed to the limit. From the fragile wooden frames of 1914 to the hypersonic, uncrewed ghosts of the future, this century of development is an absolute triumph of mechanical evolution and high-stakes ambition.
So I'm going to leave you with this take-home assignment. As we approach the year 2050, how do pilotless, hypersonic, and suborbital systems change the ethical and strategic calculus of warfare? When a machine can strike anywhere on Earth in 2 hours without a human on board, how does that shift deterrence? Think critically about this as you continue your studies. Thank you for attending today's briefing, cadets. Keep analyzing, keep questioning, and I'll catch you in the next explainer.